right, so as Michael said, I will talk about more details about how KSQL actually runs your queries. If you went to Neil's talk yesterday, he provided you with basic concepts and fundamentals of KSQL. In this talk, we are going to show how KSQL actually does those things that Neil showed to you. And one extra point I want to make before I forget, after this talk at 11:20, Robin Moffett is going to give another talk about KSQL, which is going to be more about like how to develop applications and pipelines with that. All right, having said that, I'm Hojjat Jafarpour. I am in software engineering Confluent, working on KSQL, and this is my contact. In this talk, I will talk about these points. First, I'll give you a quick introduction about KSQL, although most of you may have been in Neil's talk yesterday, just to make sure that everyone is in the same page and we have the same understanding what we are talking about. And then I'll take you through the journey of stream processing in Apache Kafka, which are these 3 steps. And I show that how initial good old times stream processing was in Apache Kafka and how we arrived to this point with KSQL. And after that, we're going to deep dive inside under the hood to see what's happening under the hood in KSQL and how your queries are being processed. All right. As you may know by now, KSQL is the streaming SQL engine for Apache Kafka. It is zero coding, only SQL statements, and if you consider SQL as no coding. It provides a very simple way to run your streaming applications. You just declare your streaming application in KSQL statements, and everything else is being taken care of by KSQL service for you. So it runs on top of Apache Kafka and Kafka Streams and inherits all of those good properties that they have. It's scalable, it's battle-hardened, because Kafka is battle-hardened, and it provides a really easy way of expressing your applications without thinking about how the details of application is going to work in the Apache Kafka. A lot of applications, you can use KSQL to implement them. One of the very common one is streaming ETL. You can have continuous queries doing transformation on your data and preparing your data for next stages. Here's an example that you enrich a user stream with user information by joining it with a user table. Another very common application Neil also talked about yesterday is anomaly detection, although we are simplifying it here. But of course, this is the first step. You can actually have much more complex applications with it. Other applications, real-time monitoring, very common application. You have a bunch of logs from different systems, and you want to make sure that you catch any anomaly, any problem in your system. You can define continuous queries using KSQL, and it's going to write to the result or sync topic whenever the declared behavior happens in your system. So now going through these examples, we know that what KSQL is. Let's go back and see how we arrived to this point, how we started from Apache Kafka, and step by step see what was the journey of stream processing on top of Apache Kafka that took us to KSQL. So we have this famous graph that usually we use in most of KSQL presentations. And it shows the trade-offs that you have or the preferences you can have in picking up stream processing platforms. So in good old days, when you had Kafka without any other stream processing platform on top of it, you had to write a lot of things yourself. And Kafka provided the API for doing this for you. Producer-consumer are basic and fundamental API that Kafka provides for you to be able to use your data from Kafka topics and generate new type of data and write it back to your topic. Producer-consumer uses one of the very important properties of Kafka, which is consumer group protocol. In consumer group protocol, the consumers that are using the data from a Kafka topic can easily scale out, can deal with the failures, and can do a load balancing automatically without you worrying about anything. Let me just give you a quick overview of how some of these properties of consumer group protocol work. So imagine you have a topic in Kafka, you have multiple partitions for this topic, and you have a group of consumers. Each of them are consuming part of this topic. So consumer group is going to be assigning the partitions to each of these consumers, and they are going to be using the topic data from each of these partitions. Sorry. So now imagine that you lose one of these instances. Again, consumer consumer group protocol is going to rebalance the assignment of the partitions, and without your consumers needing to do anything, everything is going to be handled by the consumer group protocol. Now imagine you want to scale out your consumers. You add more nodes to the consumer group. Consumer group, again, rebalances the load and assigns proper load for each of these consumers that you have. So as you see, it provides a very fundamental and very strong concept here that you can start building on top of this. And based on that, your application is going to inherit all of these nice properties that you have.